Welcome back. In this clip, I would like to create nParticle with emitter type as a surface. We also would like to create an effect in which nParticle can inherit or extract the color values from the given texture. So let's get started with that one. We'll create a polygon surface and just rescale this. This is a simple sphere. Now go inside the nParticle menu and inside the emit from object, go inside the option box. Make sure we are working with the reset settings. Now with the very default settings we have the emitter type and this is set to the Omni. Let's create this. As we all know, the particles are still under the impact of the gravity, so let's disable the gravity. And now if I play the timeline, you'll notice the particles are now actually emitting from the per vertex of this polygon surface. But at the moment I'm not looking for this effect. What if I want to emit or distribute the particles on all across the surface? So for that we need to go inside the emitter node, and instead of the emitter type Omni, let's pick the surface. So with the type surface, it will going to distribute the particles on all across the surface. Now let's play the timeline. And now you can see if I play the timeline, these particles are moving away from this surface. And the overall quantity of the particle is also very less. So let's do one thing, let's increase the overall rate of the particles significantly. So let's do one thing, let's make it somewhere around the, let's say 10,000. Alright, and now if I play the timeline, you can see these particles are now moving away from the surface. And if I take you to the top view, you can also notice these particles are also creating some kind of patterns. Let's also increase the time slider and play the timeline once again. So first we need to configure that what exactly is the cause of this kind of an effect and what makes particles to create this kind of motion or this kind of the behavior. So let's do one thing, let's go inside the emitter node, and inside the speed attributes we have the speed and speed random, and we know what these two attributes can do. What about the tangent speed and the normal speed? So normal is basically the reference vector which is perpendicular to the center of the face. If I select this sphere and enable the display normal, you can see we have these green lines which are located at the center of the face and they are perpendicular from the center of the face. Let's increase the normal size to the 10. And now if I play the timeline, let's go to the emitter node, and if I play the timeline, you can see these particles are trying to follow the exact directions of the normals, because now the speed is actually based upon the normal speed. We can also increase the value of the speed, and you notice the particle will going to move a little bit more faster, and notice they are actually following the exact directions of the normals. Alright, so this is the concept of using the emitter type as the surface with the normal speed. Now let's do one thing, let's explore the another attribute, that is the tangent speed. So let's make that thing 0, and let me select the P sphere, and instead of the normal let's use the display tangent. Let's get rid of the particles. So this is basically the tangent of this surface. Let's reduce this thing to the 5, and let's go inside the emitter node once again. So normal speed is the attribute of the speed which will send the particles away from the surface, whereas the tangent speed is the attribute of the speed which will let the particles to follow along the surface. So this is the only difference. Alright, now let's do one thing, let's use the tangent speed to a value of 1. Okay, let me go inside the P sphere, and now I play the timeline, and you notice these particles are trying to follow along the surface tangents. Okay, now let's just disable this and play the timeline once again. Let's also do one more thing, let's get rid of this particle count. It seems to be very high, so let me use only 1000 particles. So now you can see these particles are flowing along the surface. Alright, we can also create one more interesting effect with this. What if we have the speed set to the 0, And now if you set the speed to 0, nothing will going to happen because particle will going to emit or start getting distributed on all across the surface, but they won't able to move. So the speed is really very important. Let's do one thing. Let's use the speed random to a value of zero point 0.1, and now let's play the timeline. So you can notice these particles are actually moving really very slowly, but they are creating a very nice effect. Let's change the value to, let's say, 0.25. Alright, let's get rid of this wireframe on the mesh, and now let's play the timeline. And you can see these particles are slowly moving, but they are creating a very nice and interesting effect. Alright, so that was just all about the particle type with the emitter type as the surface. Now let's do something interesting. Let's go to the emitter node and increase the rate again. Let's say this time we would like to go with the 50,000 particles, and I also want to provide some textures to this polygon surface. So let's go inside the hypershade, and over here I have two textures. One is the ramp and another one is the UV map. Let's apply the UV map to the color of this Lambert and press the 6. Okay, now if I play the timeline, you can see these particles are emitting from the surface, but now what I want the particles should also inherit the color values from this surface. Alright, let's do one thing. Let's go inside the emitter node and let's get rid of this speed and everything. Alright, now pretty much fine. So how are we going to do this? Well, if you go in the bottom sections, we have texture emission attributes. We need to enable the inherent color, but the moment I click, I can see a warning appearing over here and saying that nParticle shape 1 doesn't have the following attribute RGBPP. Now this RGBPP stands for the color per particles. So we can get this. We need to go inside the nParticle shape node. Now under the add dynamic attributes, go over to the color and click the option add per particle attributes. Alright, and now come back to the emitter. So you can see we have the particle color. So we are also required to put that file texture inside the particle color. So go to the hypershade and go to the textures. Now bring the color texture over here, and I can do one thing, roll back the timeline. Let me just hide the sphere and now play the timeline. So you can see very beautifully these particles have now inherited the colors, and whatsoever was the UV image or that texture, these particles have wonderfully inherited the color values. Alright, so this is something really very nice. But let's do one thing. Let me give you one more condition. What if we want to sample only few section of the sphere? So instead of applying the particles to all over the surface of the sphere, what if I just want to emit the particles only from specific areas of the spheres? Or what if I have some paint in my hand, I just want to paint the overall surface of the sphere and just want the particles to emit only from that surface which is painted. So that can be possible. Well, go inside the emitter node and we have the texture rate. If we use the enable texture rate, we can provide a grayscale or an alpha map over here. So from white pixels the particle will emit. So let's move to the hypershade, and I've already created a RAM texture. Let's drop this RAM texture inside the texture rate. Okay, now if I play the timeline, you can see the particles are appearing only from those color values which were having the white pixels, and this is something which is really very interesting, and this is, I should say, a sky high concept, and this will going to open lots of possibilities to create nice effects. Alright, so let's do one thing. Let's take a pause from this clip, and in the next clip we'd like to begin with the another nParticle emitter type, that is the curve. So let's end this clip over here.